3 in your book. So we've got arithmetic, we've now got geometric. Geometric is a sequence in which ratios of consecutive terms are equal. So basically, in a nutshell, what does this mean? In an arithmetic sequence, we add or subtract the same number. In a geometric sequence, we multiply or divide by the same number. So that's what this means. So arithmetic is you add or subtract by the same number. Geometric is you multiply or divide by that same number. And so here's our explicit formula for a geometric sequence. Okay, this is what we call our explicit formula. A sub 1 first term times my ratio, okay, to the n minus 1 power. R is your common ratio. Now this is the key thing that you need to get down from this whole slide if you take nothing else from it. You find the ratio by taking the second term divided by the first. Okay, now that sounds weird, but you take second divided by first. A lot of people want to take the first and divide it by the second. That's not. It's going to be off. Second divided by your first. And then to check it, you always take then the third divided by the second. So, and that might not make a whole lot of sense until we actually get into a problem, but here's something else to get down and to understand. If you know the nth term of a geometric sequence, so like if you would know the 50th term or the 100th term, you can find the n plus 1th term. That's the term right after. So that would be like the 51st or the 101st by just multiplying by r. So, and that's something that a lot of people don't maybe understand. So if you know the 50th term, if you want to find the 51st term, you take the 50th term times your common ratio, or divided by that. All right, so now we're going to jump into some examples. And so today our tasks are going to be to write sequences, okay, write explicit formulas, write recursive formulas. We're going to find the sum of a geometric series. Okay, and like I said, we're going to have probably a longer lesson today, and then tomorrow, since I'm going to be gone, you guys will have time to work for those of you that are here. Those of you that aren't, then you'll just have to either do your homework sometime over the weekend or tonight. Okay. So let's go ahead and look at the first one. Determine the common ratio, and then find the next 3 terms of the sequence. Determine the common ratio, and find the next 3 terms of the sequence. So now, in looking at this one, the ratio isn't obvious. Okay? It's not blatantly clear what it is. It's not like a 2, a 3, a 4. And actually, in looking at it, it's got to be a decimal. So if you remember how I said to find the common ratio, we take the second term divided by the first. Second term divided by the first. And so what does the common ratio come out to be? 2.75. There's your common ratio. So what that means is that in order to get to the next term, you're going to take 30.25 times 2.75. Okay? So what is 30.25 times 2.75? What? 83.175? 83.1875. Now you can do the same thing. You're going to take 83.1875 times 2.75. What do you get? 228 point what? Okay. Then you're going to take that number times 2.75. Okay, there you go. Those are your next 3 terms.
I thought he wants to go.
Was it keeping going?
No, but that was it.
It won't be that. This is just one of those ones that's a little longer. Most of the times they won't be that long. Let's look at another one. There we go. Find the common ratio. Oh my goodness. We got R in there. Good times. So I take the second divided by the first. Okay, so now now, right now it's not really clear what the answer actually is. So what I'm going to do on the top is I notice that 16 goes into both. So if I factor a negative 16 out, I get r minus 2. On the bottom, great, thank you. If I factor out a 64, I get r minus 2. So what happens to your r minus 2s?
Cancel.
They're gone.
Yes.
And then I end up having negative 16 over 64. So what is your common ratio going to be? Negative 1/4.
Yes.
Wait, okay, so I figured that out that way.
You might have. Yeah. You might have been able to figure it out and look and see, ooh, the relationship is that the top is a negative 1 and the relationship on the bottom is 4, and that's fine. Okay? And so you can go ahead and use that as well. Doesn't matter.
How'd you figure that out?
All right, so now we need to find the next 3 terms. So the next 3 terms. So what would the next term after 4r minus 8 be? Hey, what would be the next term after 4r minus 8? Basically, this is the easy way to do that. Take each of them times negative 1/4. So you get negative r plus 2. Now what I'm going to do is take negative 1 divided by negative 1/4. Okay? Or not divided by, negative 1 times negative 1/4. So what do you get there? 1/4 r minus 1/2. Now I'm going to do the same thing. I'm going to take 1/4 times negative 1/4. And I'm going to get negative 1/16 r. And then negative 1/4 times negative 1/2 is plus 1/8. And there you go. Okay. So let's go ahead and look at the following. It says, write an explicit formula and a recursive formula for finding the nth term of the geometric sequence. Okay? So, write an explicit formula. So let's go ahead and start. So our formula, if you remember, was a sub n equals a sub 1 times r to the n minus 1 power. Okay? So what's my first term going to be? 8. Now I need to find my ratio. So to find the ratio, remember I take second divided by first. So in this case, my common ratio is going to be negative 2 divided by 8, which is negative 1/4. Okay? So now, there you go. That is your explicit formula. Now what I need to do is come up with the recursive formula. So the recursive, if you remember, where do I always start, or what is in every recursive formula?
First term.
So tell me. A sub 1 equals 8. My next one is going to be the relationship between a sub n and a sub n minus 1. What's the relationship going to be? Yep, negative 1/4 times. And there you go.
Is that
It's-
Yep.
So that's a subscript.
Yep, that's a subscript n minus 1. Yep, and the top one is an exponent. All right, let's go ahead and look at another one. Okay? So another one. We need to use the formula a sub n equals a sub 1 times r to the n minus 1 power. So I know that a sub 1 is what? 2. Now I need to find the ratio. So to find the ratio, I'm going to take 25 divided by 2. So the ratio will be 12.5. So I'm going to take that times 12.5 to the n minus 1 power. So there's your explicit. Now the recursive.
A sub 1 equals 2.
Okay, on the recursive, we always have a sub 1 equals 2. That's going to be the part of every recursive formula. Every recursive formula have a sub 1 equals. Now we've got to have the relationship between a sub n and a sub n minus 1. Now, real quick, if you remember, when we had the arithmetic, it was either a sub n minus 1 plus or minus whatever number we used. With the geometric, it's going to be multiplied or divide. So in this case, it's going to be 12.5 times a sub n minus 1.
But that's only on the geometric.
That's on the geometric sequence. Geometric will always be multiplied or divided on the recursive. Arithmetic will always be added or subtracted. Okay, find the 27th term of the geometric sequence, 189, 151.2, 120.96. Okay. We will write an equation, okay? So, my equation is going to start a sub 27, because that's the term I want to find. What will come next? 189 times r, which we need to find. 151.2 divided by 189. What does r equal? Yep. It comes out to be 0.8 evenly. 151.2 divided by 189? Okay, good. I was worried. I was thinking, oh, I don't think it should be. So 0.8 to what power? 27 minus 1. Yep, n minus 1. So in this case, 27 minus 1. So really, the power that I'm going to use is going to be 26. Okay? So now, on your calculator, how you do this? You have to do the 0.8 to the 26th power first. So do that. Take your answer times 189.
0.57.
0.5712. I've heard 2 over there. Is that what I got over here? Yep. Okay. So 0.5712. Okay. So questions. All right. Find a sub 9 for this. You find this one for me. Let's go. Find a sub 9 for 4, 14, 49. 4, 14, 49. Find a sub 9.
Got a big answer. That's a big answer. Did you get like 2,000 something?
You did. Oh, man!
Okay, so when you do this, you should get 3.5 to the 8th power. Take that times 4. And when you do that, what do you get?
90,775.
Okay, now some of you are probably wondering, well, how could it be that big? Your ratio is 3.5, so you're taking it times 3 each and every time.
Yeah.
Okay, so of course it's going to be a big number when you're doing that. All right, find a sub 12 if a sub 3 equals 32 and r equals negative 4. Now this one's different because in order to use our formula we need to know the first term, and we don't know the first term.
But we do know R, figure it out.
But we know r.
You can do this.
Okay. So, if you notice, what I do each and every time is I take it times negative 4. So this is my third term here. I want to go back here and find my first term. And so in order to undo a timesing by negative 4, I divide by negative 4. And when I do that, what do I get my second term then to be? Negative 8. So now you're going to do the same thing. You're going to divide by negative 4 and you get 2. So now we need to find the 12th term. To find the 12th term, I know that my first term is 2. I know that my ratio is negative 4. And I know that the power I'm going to use here is what? 11. So take negative 4 to the 11, and you think the last number was big. I think this one's probably going to be just as big, if not bigger.
Much.
Actually, it's a lot smaller.
Well, smaller because it's a negative. Yes, you're correct. Good call.
Negative 8,388,600.
Do I have a second?
It's
I second that.
It's what?
No, it's a
No,
sheep.
no,
I
continue on.
second that.
Yep.
Okay.
You have a
Good.
dummy in our presence.
Good job. Okay.
Slice it open.
Okay, so here we go. All right, so the last thing we're going to talk about now is how you find the sum. Now, if you remember, we did this with the arithmetic. We split it up over 2 days. We're going to go ahead and find the sum today. Now, there are 2 formulas that you can use. Now, both of these formulas are equivalent. Okay, so if you want to go ahead and get those down. Okay, I'll Okay, now there are 2 formulas, and so based on what you're given in the problem, you're going to probably have to pick what formula to use. I will tell you right now that both of these are listed in your book. Up until this point, I had just been dealing with the one that was on top. Okay, that was the formula that I used on both, but there is another one that you may use as well. Okay, so we got them down. Let's go ahead and look at an example then. Find the sum of the first 6 terms of the geometric series. The first 6 terms. So we could use either formula. I would probably use the top formula because we don't know what a sub n is. We don't know what the 6th term is. So in order to use that top formula, I need to figure out what the ratio is. What's the ratio going to be here? 14 divided by 8? 1.75. So the formula we're going to use is S sub 6 equals, okay, A sub 1 times 1 minus r to the 6th over 1 minus r. So in this problem, A sub 1 is 8. I'm going to take 1 minus 1.75 to the 6th power, and I'm going to divide that by 1 minus 1.75. Okay. So 1 minus 1.75 to the 6th power, divide that by negative 0.75, and then take that answer times 8.
12.7.
You give other people a chance. No.
Mason, what'd you get?
I got negative 29.
There you go, 295.71. Okay. So far, so good? Oh, got it? Okay, let's go and look at another one. Find Find the sum of the first n terms of a geometric series with a sub 1 equals 3. Wow, look at that a. Sorry, I made it a subscript. It should be a bigger.
Oh my.
Here, it's supposed to be here. Here, we'll make that an a. There we go. With a sub 1 equals 3, a sub n equals 768, and r equals negative 2.
Maybe the first end you can charge us now. I feel like we're gonna jump back.
So, we're going to use the second formula. Okay? We're going to use that second formula because we're given the first term and the nth term. Now, come test time, you're going to be able to have a note card, so you'll be able to have all these written down. You don't have to memorize them. So, S sub n equals, what's my first term going to be? 3 minus 768 times negative 2, all over 1 minus negative 2. Okay. So, 768 times negative 2 is negative 15, what is that? Negative 15, 18, 36. So you're going to have 3 minus negative 1536, which should be 1,539 divided by 3. So when you calculate that, you end up getting 513. So based on what you're given, you get to decide which of the two formulas you're going to use. So far, so good? We're about done. We got one more to talk about. Sorry, we got one more to talk about. And that's what happens if we have an infinite geometric series. Now the nice thing about an infinite geometric series is that it will converge upon some value, which is kind of what we did in the first section. Okay? So if the series is infinite, that means it goes on forever and ever and ever. How can we find the sum? There is one way, and that is provided that r is less than 1, that absolute value. If the ratio is bigger than 1, it doesn't exist and you're done. So that's the first thing you need to check. If the ratio is less than 1, the absolute value, that's the only way it will work.
It's a good thing it's the ratios are along that way.
Yeah, because then you're done. You just say the sum does not exist.
Should put a couple of names.
Who knows? So we've got one more problem we're going to look at. Find the sum of the infinite geometric sequence. Okay. So now, you're probably wondering, oh my gosh, that doesn't look like anything we've looked at. And you're right, it doesn't. So we've got to talk a little bit about what it means. That tells you it's an infinite geometric sequence because of the infinity sign. All that does is that tells you that it's an infinite geometric sequence. 4, that's your a sub 1. 0.6 is your ratio. And if you notice, the rest of it fits into the formula that we were writing. So the very first thing I need to check is r, the absolute value of r, less than 1?
Yes.
Yes, it's 0.6. So I can find the sum of this series. And the sum of this series is defined as being a sub 1 over 1 minus r. First term is what? 4 divided by 1 minus 0.6. So what is the sum of this infinite geometric, which is what? 10. There you go. Okay, pretty straightforward. Once again, you check the ratio though. If that would have been 6, you would have stopped and said no sum exists. Okay, this is your assignment. Okay? 1 through 8. 1 through 8 just is determine the common ratio, find the next 3 terms. 10 through 17 is write an explicit formula and a recursive formula. 20 through 27 is find the specified term. 32 and 33 is to find the indicated geometric means for each pair of non-consecutive terms. And 40 through 44 is to find the sum. You know what? We didn't cover geometric means, so I'll cross those off because we didn't get to geometric means and we had a long enough lesson. It's page 615, sorry. It should be page 615.
I was gonna say, that doesn't work for me.
Here, I'll change it up for you. There we go, page 615. And there we go.
Oh gosh, now who got me this word?
There you go. Okay, there's your new assignment. Page 615, 1 through 8, 10 through 17, 20 through 27, and then 40 through 44.
Together with the combined powers of the universe can be created.
What's the difference?